started here. The first form I want us to talk about is what's called factored form.
Oh, wait, wait a minute. Oh, yeah, okay. Well, okay, I know about quadratic functions. I'm sorry about that.
No, let's do a few examples here and see, just for review. Is that okay?
Yeah.
Unless there's something else you'd like us to work on that's more important than this, but we can do a little bit here and move on to something else. Let me give you a couple of problems.
Can you help me learn about like can you please help me on the let me check.
Sure, I will stand by.
Yeah. I'm let me just find it.
No problem. I'll stand by here and wait. No problem at all.
Yeah. Linear inequalities and equations
Okay.
and functions. Linear.
Okay. Yep, we can do that. You said inequalities? Inequalities like greater than, less than, is that right?
Yeah. Inequalities.
Okay. Yeah, we can absolutely do that. All right. Yeah, so let's just look at something here. Move down here. Come on, give me some more room here. Yeah, so we'll look at linear inequalities. And let's start with a number line here. So this number line, it goes from minus infinity to infinity. Okay. And give me your favorite number here. Do you have a favorite number, if any?
My favorite number.
Yeah.
I will pick 10.
10. All right. Now I'm going to put a filled in dot here, and we're going to fill in everything to the right.
Okay.
Okay. So here's what this means. This means x greater than or equal to 10. Okay. And you can see how the arrow is pointing right. That means it's everything to the right. This line underneath is because it's a filled in bubble there. So let's look at another one here. Let's look at another number line, minus infinity to infinity. This time I'm going to fill in a bubble here at 10, but I'm going to go left. Okay.
Yeah.
So this is x less than or equal to 10. Do you see the difference? Do you see how the arrow is pointing towards x? This line underneath is because this is a filled in dot.
Yeah.
Is that clear to you? Have you seen that before?
No, it's my first time seeing it.
Okay. Are you sure this is what you want us to work on?
Yeah, because I hope that it's going to be there maybe next time.
Yeah, a good possibility. Okay, so let's do another example here. So again, if I draw a number line, that's all the numbers from minus infinity to infinity. This time though, at 10, I'm going to just make a non-filled in circle and go everything to the right of it. Okay, so the difference is that now it's x just greater than 10, just greater than 10. So I'm not putting that line underneath because this is not filled in.
Okay.
Okay, and then similarly, Similarly, minus infinity to infinity, here's 10 again. I will not fill it in. Go everything to the left. Everything to the left, and this is x less than 10.
Okay.
Okay. So I'm gonna go back over these one more time. I'm gonna put the words down. Greater than or equal to. That's
Okay.
what this symbol means in here in the middle. Greater than or equal to. This one means less than or equal to.
Yeah.
Okay. Now the difference down below, when we don't have that line underneath, we just say greater than. Greater than. And when we don't have the line underneath, we say less than. Okay, so you want to be able to like use the right language to make this clear when you're speaking about it. Okay.
Mhm.
So we're going to solve two-step linear inequalities.
Linear inequalities.
Yes.
Okay.
It's not going to be that bad. 2x minus 3 is greater than 8.
Yes.
So here's what I want you to do. I want you to imagine that this is really on the right, 2x minus 3 equal to 8.
Okay.
Do you know how to solve this one on the right? Actually, let me change this number to 7, just to make this nice. Do you know how to solve this one on the right? Do you remember how to solve two-step linear equations?
Yeah, maybe you have for that
So here, like
negative
here,
3,
you're going to add 3 to both sides.
add 3.
So you have 2x equals 10.
2x equals 10. Okay.
Then you divide both sides by 2.
And then
And
it equals x equals 5.
right. So I want you to do the same steps over here on the left. Exact same steps. Okay.
Yeah.
And what
Okay.
can you do that for me on the left? On the left?
Yeah.
Okay.
Okay. Okay. Can you help me on this one?
Sure. So we're going to add 3 to both sides.
Okay.
So it's 2x greater than 10.
2x greater than 10.
And now we're going to divide by 2 on both sides. So
That
x
can
is greater.
equal like 5.
But see, it's a greater than symbol.
Okay.
So it's the exact same work, same steps. You just have this greater than symbol.
Mm-hmm.
Okay. So now we're going to graph this. Okay. So here's our number line. Here's minus infinity and here's infinity. I'm just going to put 5 right in the middle. Okay. Now, because it's greater than, not greater than or equal to, that's a dot that's not filled in. Okay. And am I going to shade to the right or to the left? And it depends on this right here. See how it's pointing to the right? You want to shade everything to the right here.
Yeah. Okay. All right. That is like x less than 5.
Well, that would be over here to the left. This is x greater than 5.
Greater than
X
5.
greater than 5.
Okay.
Okay. So now let's try another one here. So let's go 4x plus 1 equals, I'm sorry, 4x plus 1 less than 17.
Okay. All right. Okay.
So we want to solve this, right? We want to solve it by subtracting 1 from both sides and then dividing by 4. So do you want to try that on your own?
Yeah. Yeah.
Okay. Go for it.
2 greater than 2 greater than 6.
Okay, so let's subtract 1 from both sides. Okay, subtract 1 from both sides. So this is 4x less than what number here? What is 17 minus 1?
17 minus 1, 16.
Yes, 16. And then divide both sides by 4.
Ah, yeah.
So x is less than what number?
4.
4. Very good. Okay, so now we're going to go to our number line here. We're going to put 4 right in the middle. There's no line underneath, so it's an open circle or a bubble, open circle bubble here. Am I shading left or right? It's all based on this right here. That tells
Right.
left. This is left. This is
Left. Okay.
x less than 4.
Okay.
All right, let's try another one here. 3x minus 2 greater than or equal to 13. So give this
Okay.
one a try on your run, please.
All right. X greater than 13. No, 5.
Okay, so yeah, I think that's pretty close here. I'm gonna, the wording is really important. So maybe you wrote down the right thing, but it's x greater than or equal to 5. X greater than or equal to 5. Okay,
Okay.
so go to
So
your
that's
number.
X less than 5, right?
No, it's greater than or equal to.
Okay.
This symbol means greater than or equal to. Okay, so here's 5. And because of this line underneath, it's a filled in dot there. And do you shade to the right or to the left? And if you're not sure, this one tells you it's pointing to the right.
It points to the right.
Yes, and that tells you which direction to shade. You shade right, you go this way.
Yeah.
Okay. Now, we'll come back to this, but I think there's some things that are unclear. So let me ask you some following questions. Is 7 greater than or equal to 6? Is this true or false? Is 7 greater than or equal to 6?
All right. So that false.
Okay, so why? Can you give me an example
Because
here?
it's because remember it's not greater than 6. 7 is greater.
So the question here is like, would you rather have, like, is 7 more than 6?
Yeah.
Yes, so this is true.
Mhm.
Because 7 is bigger than 6. Now,
Okay.
now is this true? Is 6 greater than or equal to 6? True
Yeah,
or
yeah.
false?
True.
It's true because they're exactly equal to.
Yeah.
All right, good. Okay, so let's do a little bit more here. Let's go 5x minus 7 equals Let's go 13. I'm sorry, less than or equal to 13. Okay, so go ahead and solve this for me, please.
Okay. X greater than or equal to 4.
You cut out a little bit. Let me, I think I heard it though. I think I heard X less than or equal to 4. Is that right?
Yeah.
Excellent. Okay. So now on a number line here, we'll just put 4 right in the middle. Is it a solid or is it a fill? Is it, I'm sorry, is it an open circle or is it a filled in circle?
All right. It goes at the left.
Right. But is it an open or a filled in circle?
A filled in circle.
Filled in circle to the left. Good. Okay. Excellent. Okay. So there's a small little wrinkle, okay, to these problems. All right. I'm going to throw it at you now. We'll see how it goes. If you multiply or divide by a negative number, okay, here's what happens. So if you multiply or divide by a negative number, greater than goes to less than. Less than goes to greater than. Greater than or equal to goes to less than or equal to. Less than or equal to goes to greater than or equal to. So essentially you flip, in all these cases, you're flipping or switching, whatever word you like, flip switch the inequality. Okay. So now an example, because I mean, it's like, okay, that's great, Matthew, but like, how would I actually use this? So let's look at an example. Negative 2x plus 1 equals 5. I'm sorry, less than or equal to 5. Okay. So we're going to subtract 1.
Yeah. Yes, that's right. So that equals x greater than or equal to 4.
It's minus 2x less than or equal to 4.
Oh, wait. I'm sorry, but I'm sorry. 2. X greater than or equal to 2.
Right. Well, it's negative 2 because you now you switch this because you're dividing by a negative, and then it's negative 2 there.
Okay.
So here, this step right here, because you're multiplying or dividing by a negative, you have to flip the inequality.
The inequality. All right, that's gonna
So
make
see
me,
how this flips?
that's gonna be very good since I learned that next year.
Absolutely. So let me have you try another one here. Or let me have you actually try this one. Minus 3x plus 4 I'm sorry, greater than or equal to. Why do I keep doing? Why do I keep doing this wrong? Greater than or equal to. Let's go. Let's go 10. Let's go 10. So give that a try, please.
Okay, Matthew. X greater than or equal to 2. I mean, no, x less than or equal to -2.
Okay, so I think I heard the right answer there. I'm just going to subtract 4 from both sides. Minus 3x greater than or equal to 6. Now you don't flip it yet. Just because you subtract by a negative, you don't flip it. But when you divide by a negative, that's when you flip it. So that is absolutely correct there. So here's -2. You put in a filled in bubble, circle, whatever you want to say, and then it's pointing left. So it's everything left here. Everything left there. Okay. All right. Very good there. So here's a couple of other questions here to ask you. Is 2 less than or equal to 2? And this is like a
Equal
true,
to.
this is like a true false. Like, is this a true statement?
It's a true statement.
It sure is. Is -2 less than -2? Any idea here, or would you just be guessing?
I know that answer. I know it. I know that. That is false.
It is false because they're exactly equal. So unless that line is there, it's false. Now this one is a little bit more challenging here. It's okay if you're not sure here. We can go through together. Is -2 less than -3 or -3 less than -2? Which one of these is true?
The first one.
So let's look at a number line here. And here's 0. Here's -1. Here's
Oh,
-2.
wait. I would just say that it's gonna be either I would just say it's the second one because the negative is very bigger because the negative is after -2.
Right. And it's the one that's more left. So this one is true because it's more left. Like
Yeah.
-3 is left of that. Okay. The negatives are always challenging because here's what you could do. -2 less than -3 or -3 less than -2. You could divide both sides by -1. What does that do to the inequality?
It is like it's a positive.
It flips it, the inequality,
Yeah,
inequality.
into less than.
No, greater than. This is less than, it becomes greater than.
Okay.
Okay. Or when you divide both sides by negative here, is 3 greater than 2? So now which is true? Is 2 greater than 3 or 3 greater than 2?
3 greater than 2.
Right. And that's consistent with what you said back up here. All right. So let's try another one here. Is -3 greater than -4 or -4 greater than -3? And you have a choice here. You can either draw this on a number line, or you can divide all of these by -1. It's up to you. You get to decide here.
Okay. Yeah. Okay. Okay. I would. Okay. I will just say it's the first one.
All right, so here's what I'm going to do. I'm going to divide both by -1. So what does that do to the inequality when you divide by negative?
It switched it to 4,
Right.
-4.
Right. And then I'm going to do the same thing over here. And now it's usually easier with positive numbers. So is 3 less than 4 or 4 less than 3?
4, 3 less than 4.
Very good. Okay. All right, so let's just do one more here. Let's say I give you -2x plus 7 less than -21. I'd like you to solve this for me, please.
Okay. I'm solving it.
Excellent.
X less than 7.
Okay, did you subtract 7 from both sides?
Yeah, I did. I did.
Okay,
I
so
did.
so this actually becomes, it's negative 21 minus 7, so that's negative 28.
Okay.
Okay, now you're going to divide both sides by negative 2. When you divide by negative, what do you do to this inequality here? You have to flip it. What is negative 28 divided by negative 2?
14.
14. Very good. All right. Do you want to do one more like this, or do you want us to stop here?
I think we're gonna stop here.
Okay. Do you feel like you understand this better than when we started?
Let me okay. Let me just let me just write these down. Can you go at the top?
Sure. I mean, I'm going to send you the notes here.
Okay, yeah, you
Shortly.
can send me the notes. You can send me the notes.
Yeah, I've been sending them to your dad by email, so he can absolutely, send them to you. However you guys want to work that out.
Yeah,
Yeah.
I think so. Yeah, I'm next time when we next semester when we do equalities, then I'll be prepared to use the notes that you have helped me on.
Excellent. So why don't you grab your dad, let him know we're all done for today,
Hey, Dad.
and give him some feedback.
Yep.
Yeah, hi.
Hi, sir. Hey, Dr. Kithari. So Sourish did a great job today again. He wanted to work on linear inequalities, something he will see next semester. I think he definitely understands them. There's more advanced ones that we can do next time or whenever we meet again, but I think things have been going real well. With him, how is his grade in class, and is he, have you seen any improvement throughout the semester?
Well, in math, it's like what is it? B plus something?
No,
Right, Sourish? No, wait a second.
let me
It's here. I'll tell you. One
no,
second.
I got it.
But again, we have to wait for the
Oh,
final
shoot,
semester, right?
wait.
So algebra A minus.
Excellent, excellent.
Yeah.
Because my teachers are helping me on some of it.
Sure, but you're doing the work yourself as well in the exams.
Some of it, yeah,
and,
a little bit. If I
and you're putting time in here. I mean, I think we can reasonably assume the same goal for next semester to get stay right there with that grade.
Yeah.
He's absolutely capable of doing this. I think he's doing a great job. Starting in January, we can increase the length of the lesson maybe to like 40 minutes.
Yeah.
And see if that.
yeah.
I think this is going well. It'll be easier when he's got new stuff that he wants to tackle rather than just review of old stuff.
Right. Yeah. Okay, great. Yeah,
Great.
happy holidays and
Yeah, happy holidays. Thanks.
Yeah,
thanks so much
Yeah,
for
happy
scheduling
holidays, and can you send the notes for what we did today, the equalities?
Absolutely. I'll send them out to you shortly.
Yeah, so I can be ready on that when we do equalities next time in Mr. Brown's class.
Excellent.
Yeah, thank you.
Okay, thank you guys. Have a great night.
Yeah.
Yeah. Have a great Christmas break, Matthew.
Thank you. You too. Enjoy your time off.
Yeah, Merry Christmas.
Merry Christmas. Bye now.